Hello and welcome back. In the last video, we built a Galton board with some basic things like we had the cylindrical pegs, we had the ball, we had some collisions, and in this video I will continue on that, but I think I will actually go with a 3D Galton board instead. So I have changed my mind a bit about the concept. So with 3D, I mean like instead of the pegs being cylindrical and the ball just falling down with going side to side, it will be a pyramid of spheres that produces a normal distribution in like 2 dimensions plus height. And I think that could be quite cool. I haven't seen that before, and I assume the concept is the same. So as you can see from the playing animation that is running here, this is where we left off, and I'm gonna continue from that. So to pursue this new idea, I think the first thing I guess will be to make the pyramid of spheres instead of the triangle pegs. So I guess I'm gonna go back to the math of producing that triangle, and I think I'm gonna call them peg still, even though they will be spheres, because they have the same role. So I'm gonna take inspiration of the ball, because now we will use the same geometry. And so for the peg, we are gonna copy in that. We have the geometry, we have the sphere, we do radius we are already using, so we can remove that, and we should be able to remove that, but we want to use the peg material here. And the sphere we don't need to do the rotation anymore, because a sphere is the same everywhere. And yeah, that should be it. Nice. So we can see that our triangle are now built by spheres. So the next step would be like we need to build a pyramid of this, and that can be easier said than done. It's usually a bit annoying with this math to build this, but we have two nested loops. One that builds the goes vertically, and one that builds the layers. So I imagine that inside the one that currently builds the layers, we're gonna have another loop that also can build like depth for the pyramid. So I add that. So let's I said equals 0, I said equals 2, and this will probably be the same as layer count, I guess, because it's gonna be a square. So, and then y said, and I think in 3GS the Z direction would be correct here. So yeah, that's probably it. And so I should be able to do that. And now we should do more than just ignoring this dimension. So per layer height, per peg width, I think we can reuse this. And we should be able to reuse maybe this entire thing plus that one. Oh, it wasn't so hard. All right, so but the question is, do I like this look for the Galton board, or is it just confusing? I'm not sure. Like, it should be visually appealing, and it should be clear what is actually what actually happens. And maybe I can do this a bit easier to see visually. I think I'm gonna, in the meanwhile, I'm gonna ask ChatGPT how I should rewrite my collision thing, because it's like it can collide and give bounce in all directions now, since they are spheres. So I changed the, yeah, you should see as well something. Oh, I changed the pegs for this Galton board to be spheres instead of the typical cylinders. Do you see any things I need to update in the collision logic to be able to handle collisions between the balls and the new shaped pegs? That should be fine. And yeah, we can do standard thinking time, something like that. So while that's thinking, I think it's nice to have a reduced ball size, so like maybe 0.4, and actually increase the size of the pegs maybe. It still looks like kind of, I don't know, hard to visually understand. I mean, the camera could begin like this to see the circle more and then rotate it in a way. If I play this now just to see how the maybe the ball should be a bit bigger actually, because it feels like it just missed everything now. And maybe I should do this a bit bigger and the tangent loss a bit smaller. Let's see what happens now. Maybe, the collision from what I can see, it works kind of well actually. So yeah, it works fine. So that was good. And so how are we gonna do this next? I think we're gonna start to introduce more balls because we are obviously gonna need many of them to produce a normal distribution statistics. So maybe like here we create that. So why not like in a 4, or maybe let's see, new array 100 fill 0, the dirty approach to do this, and then map. We can just do that we do this, bam, bam. Yeah, like that should be fine, but actually we need to set this random starting coordinate a bit, because yeah, otherwise they're all gonna bounce the same. So we give this a full scope and set, we can do const ball equals 2, and then we do, I guess, this, and this isn't working because like that, and we're gonna do return ball, and that isn't working at all, like that ball, and then yeah, we can skip this one and do const. All right. So then we also need to actually add the mesh. And now we have a lot of balls all colliding. Yeah, I'm not sure if this actually... Let's see, if I go from the side, I should expect some kind of normal distribution happening, even if I just look from the side. So like this, maybe. Oh, sorry. And then I'm gonna take this position from here and set the starting position here to that, and remove this and use the mscene. Bam. So let's see if it actually... Well, I'm not sure. Let's see if what happens if I just... What happens if I... We try to make this... We can do the peg setup a bit bigger. So triangle depth, let's say do 10. No. Oh, okay, so that was heavy. Of course, it needed to trace the entire thing now, so that will be a lot of work. So we'll have this entire thing. Let's see if it actually can run this in real time. It seems to. I'm not so sure if this is gonna be a good animation though. Let's see, do we have any action from this side as well? So let's copy these positions, add them here. Bam. Now look at from this side. No, we don't have an action in that. Yeah, and that might be because we never gave any random position to that axis as well. So, you know, it never had any reason to bounce in that way. So I guess set here. Yeah, and this are starting to be heavy to be a scene where we do trace from start. So maybe just trace begin from current. That's going to be a lot cheaper. Now we can see exactly how they move, and then we can... I think we should do the bouncing a bit less actually, and then just... This is going to be very expensive to run, but what if I make the ball much smaller? We do it white as well, I think, just so we can see it more clearly. 1, 2, 3, 4, 5, 6. We can do it very rough for now, and then we add very many of them. So like we do 500 balls. This is gonna be tough to run. All right. This is not in real time, but we have collisions between all the pegs and all the balls. So it's still kind of fast, I guess. But the question is this really a normal distribution? What if maybe we should do like... Let's say that we do, let's say we do the ball even smaller, and that we I would like to try a bit more pegs, because it feels like a few of them falls to the side of the pyramid and then never touches anything, and I think that will break the normal distribution thing. I mean, I actually should have done more research about the Galton board. Oof. Yeah. Now it's a big triangle, and we're gonna have collisions between everything all the time for each frame. That's gonna be tough to run. So let's see how it goes. And it's also because, like, from the triangle depth, it isn't linear. Like, if we have 15 instead of 10 in depth, that isn't 50% more, because the triangle will grow, so the layers at the bottom will have, they will increase in n squared numbers of pegs, so it will be much tougher to run with a deep triangle. But I think yeah, that might actually. I think this is runnable in a render. We can even do more, but it of course will be annoying, like in the view. So maybe we should do 12 for now, and then just 100 here, and that should be much faster. Of course, we need to restart this, play. Yeah, and this is running in kind of real time. So to see if this actually is of any normal distribution, which I kind of doubt, but and even if it is, it's gonna need a lot more balls to actually produce. This might be the reason why most people go with the 2D Galton board, because the 3D one needs so much computation, but it grows with n squared in like computation. So, but why not? We can see how it goes. So I first want to increase the height of that setup, so maybe 40, maybe I'm thinking like if we do 50. Yeah, maybe even 60. And then increase this as well then, so like 65. And then I would like to have in the bottom here, like where the grid is currently, I should have like a big, I imagine a big measure board that is divided into smaller squares, smaller areas, and when a ball falls through, they increase like a bar chart, like something like that. And with that, we should see like all falling through the board at the bottom, and they fall through the smaller squares, and they rise when they get a hit. And then if they have enough resolution, these smaller squares, they should rise into like creating a normal distribution. So that is the plan. And then the question is, how am I gonna do that? And as I mentioned in the last video, I'm not too familiar with 3GS, especially not now because I haven't worked. I mean, I did the last video and a couple of videos, but before that it was a while since I used it. So from my scene, you can see this, maybe do that. From my scene, I would like to have a grid below the pyramid set up with pegs that is a like a measure of the number of balls falling into each grid square, creating a normal distribution, hopefully. And so the grid should be built by half transparent planes, and we should also be able to like extrude this to build a 3D heat map of the distribution. So it might be a good idea to build the plates from the initial plates from 3GS cubes that begin as flat. Hopefully it understands that. So that should give us some kind of base for us to build from, so I don't have to go through the documentation, which is not the 2025 method, you know. And we will see how good this idea actually works. I'm doubtful that this will, because it needs to be visually appealing, it needs to be visually understandable, and it needs to actually produce the 3D normal distribution that we wish for. So let's see. It is kind to me. No, but create bin grid, and it adds them. Let's see, mesh material, mesh box geometry, cell size, inset, stuff like that. Color for T, renormalize. I think to actually build this ourselves and not just cheat all the way through, I'm gonna ask, can you just give me the basics of the grid with the cube meshes? Yeah, and not the finished system. That should be enough to ask for, I think. Yeah, let's see what happens. Today I'm drinking tea, not coffee. It's a special day. Cube grid, create cube grid, size, divisions, wireplane, base, opacity, blah blah blah, stuff like that. It seems good. I'm not sure, like, creating a material in the loop like this is actually good. Like, we are initializing something. Yeah, it's probably just an object, but all right. So we can work from this. It's probably a good base. So you can maybe do that. So maybe here. Create cube grid. We add it with this, I think. But we already have a grid. Yeah, we're gonna replace that. Stupid me. And yeah, now we got it. So we removed the default one. And now we have this, and I think we're gonna do 100, save. Yeah, wonderful. And I'm not sure if that is gonna be enough resolution. Maybe we will do 35 for now. So that will be, so you can see here, 35 times 35, 1225 things. Still kind of smooth in the viewport. And so if I play this, obviously it's not gonna give any visual feedback for now, but just to, you know, eyeball it and see. It's a bit annoying that it's always defaulting to this, to a view. I mean, sometimes it's nice, sometimes it isn't. Currently it isn't. But need to do the hard way here. Bam, 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 bam. Play. Let's see how it goes. I mean, it seems to be more around the center at least, so that's hopeful. And then the question is, how are we gonna actually what to say? How are we gonna make the each square in the grid respond to balls falling through it? So it had some kind of idea here, which was to set cell height, grid, cube grid index. So if index we're gonna just be extremely lazy because that's the good programmer way. So how can you give me a function condition that I can use to update the squares, cubes, when a ball is falling through them, falling through, yeah, them, sure. And we could probably figure that out ourselves, but chat, this is so smart. So grid index from x, z, and bam, 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 bam. Increment cell, no. So it uses our structure, cube grid, and that contained cube here. It contained the group, the mesh, number, division, cell size, y-plane, so that have enough information for us to do the find the location of the right cube, or find the right one. So we do that, and then floor, because it's going to be a discrete value, of course. And then if it's outside, or if it's less than 0, yeah, so this is the index, and of course that can be less than 0, and it can't be more than the number of divisions in a certain dimension. We're going to return -1 because it isn't possible to find. And yeah, that should be fine. And it recommends us to, in the t-clope, after integrating position, we do this. So I will add this for now as well. My plan is that I will increase the height, but I will also do like other effects to change the color, maybe do some cool effects, maybe even yeah, we will see what can be imagined. So this should be added to your ball interface, previous Y. And that is needed because track each ball's previous Y to only count once it passes through the plane. All right, that's fair. So interface ball, bam, bam. But I think I can just do... I'm not really a fan of the underscore naming convention, so I'm just going to leave it at that. And then, of course, do this. And it's going to be on in each tick after integrating position. And we are integrating the positions here. And this became this and this. And that should be fine. Let's see if the animation works. It does, but it's kind of it's kind of messy in the distribution. I think one way, because if I do, I'm gonna need more balls to make a good distribution. But if I have more, it's gonna be a lot of computation. So one thing might be to add continuously the balls, and when they have gone below a certain point, they should be removed, and we can introduce new ones, so we can continue building the build-up of the of the distribution, and then hopefully converge at something that looks like a normal distribution from the Galton board. And then the question is, how am I gonna do that? So I guess we could do something like, we create a function that is add ball, and the only thing that should do is to add at the top, and so it should do this part, and of course it needs the scene, so dm scene, animated scene, and it should add it to a list as well, but the list is currently within the scene, and I think it will be probably the simplest, just have the list of balls like a global at the top. So let and do ball, a list of them, bam, and then we are gonna in our function create, no, not that one. It's starting to, I mean, ideally something like this should be divided into multiple files, but yeah, for this I hopefully can manage with just one file for this doing this video. But so push ball, and then we need to have some kind of thing that removes them as well. And the problem is that we're gonna need to remove them by like we can't just assume that the first one added is gonna be the first one out, because the falling pace can be different depending on random, like how it falls through the Galton board. So in some way I'm gonna need to actually remove the one that has passed, and we can't know if that will happen in order. So I mean, one solution I see now is that I just added everything, all the balls to a map, map instead of a list. But that isn't so elegant in terms of looping over. I'm not sure if it's that bad either, but since we're like looping over in a hot loop in the on each tick, yeah, but I'm not sure what choice I have either. Maybe of course one. Just for fun, in the meanwhile, I can add a lot more balls to see if it naively converges to the normal distribution. So where do I even have things? All right, yeah, I removed the function. That was a bit sad. I'll see if chat has any idea how I can solve this for my scene to actually converge to a normal distribution. I will have to use very many balls falling through. This will be too much to fall through at once for computation, so I will need to continuously add remove balls and add new ones. Maybe I could even recycle them. Yeah, anyway, let's see what chat says. So I am thinking that after they have fallen to a certain y, I can remove them and add new ones. So I never have too many to simulate. To do this, in what structure should I have the balls? Because I will need to remove ones that have passed the y limit, but I can of course not be not assume that first in will pass the limit first due to randomness in the Galton board passing. Yeah, see what it says. Even if it doesn't produce a normal distribution now, it should, I think, do that. So I think I should be able to tweak some parameters and get a normal distribution. And yeah, let's see the answer here. So great call. Treat this as a rolling object pool, so you can keep small constant number of simulated balls while continuously recycling them. So yeah, so it's on the recycling theme as well. Use a dense array plus swap and pop removal for O1 deletes. Use a dense array. So no finishes. First assumption needed. Here's a compact pool you can drop in. It pre-allocates meshes, reuses them, and support constant time retire spawn. So ball pool, inactive, active, scene, ball, GU, mat, spawn Y, constructor. What is this? GU. So, oh, that seems to be kind of standard, shared. And then material, inactive. Retire at. Yeah, so I'm gonna try that and see. It seems like it's a reasonable approach. So, bam, previous Y. Of course, we named that just that. We can do the same for this one. So active index. Sorry, index. And why is this wrong? Yeah, of course, we haven't actually defined that field. So I guess we are gonna need to do that in our interface here. Bam, bam, bam. Yeah, something like that. And so we change this. And this should be fine. And now we need to do we should add the pool of balls, and we can do the Y. Okay. Maybe that. Animated scene. Where should we add it? We can maybe add it like. Where do we even currently build? We don't. So maybe just here. And then here we have the DT last. Yeah, that should maybe. Of course, yeah. So. That. and inside here, integrate and retire. Note the manual index handling for swap pop. So I'm gonna trust it at that, like that. Pre y. Let's see what it has. So we gonna need to update this, right? No, because we don't use it. So bam, and bam on this, and let's see if this actually works. No, it doesn't. So it isn't responding to any of the collisions, but that should be some simple fix somewhere, because the collisions are looping over the balls, and so they should not be looping over those. And what should the collision loop over now to actually make the collisions happen? Do-do-do-do. So hopefully it did think of that when it gave us its solution, but it should be fine. So right now you're looping over the unused global balls array, yeah. So no collisions run. Switch all per framework to pools dense active, the dense active array, yeah. So here's a clean. But we should just be able to, if I remove this one, we should get complaints, and we should be able to just replace things. So we're gonna need to, we're gonna pool active length. No, we just should use resolve. So it should be pool active, and that is of type, yeah. So that's fine. And then I guess this one. Collisions, ball peg. I have a nested loop here, but this doesn't. Let's see what happens if I play now. All right, so something responds. And when they fall through, I think the limit is y equals to 0. So now things are recycling. But our tiles or squares at the bottom isn't reacting. So something should be wrong there, because they should react to, this is called from here, and why isn't it reacting to? Now it starts to be a little bit too much ChatGPT here, technical depth. But what I like about ChatGPT is, like, it's not, it's great, but when you write something and you aren't really certain of what you are even going to do, like live coding and stuff like this, it's quite nice to express your idea with words, and you get yourself into the right mindset by it. Is this correct? Oh, the tiles at the bottom doesn't seem to react to the balls. Oh yeah, it might be because the y limit is equals to 0. Let's see, -10. See, I caught it by writing. Or maybe it's just wrong. Who knows? But so this it is kind of slow. No, it still doesn't work. So the tiles at the bottom doesn't seem to react. Don't to the balls falling through them. I'm gonna need to leave soon because I have a class in 7 minutes. It is remotely, so I can just leave shortly before it begins. But yeah. So, this is gonna not quite. 2 issues are stopping your tiles from updating. Your update B that before you test the crossing, so and the condition never fires. Your condition resolver reassigns normal to which aliases normal to delta and can corrupt later math. Bum, bum, bum. Do parabol steps in one loop and test crossings before updating previous y. Yeah, all right. So to actually do everything in one loop over the balls, yeah, that's much smarter, of course, to save computation and also to get it right. So maybe I can put it. This does not do the spawning thing, it seems like. So it should probably be here, here, and yeah. All right. Hopefully I integrated that correctly. Everything is just black now. Something is not good. Did I do anything wrong here? I think I'm gonna end the video here. So this will be part 2 because I will need to be at class in 4 minutes. So yeah, to get into that I need to leave now, but I will return soon and try to fix this thing. So bye.